I'm very happy to be here. I'm very happy to see all of you here. My name is Oleg Šelajev. This is my first time in Chicago. Thank you. Yes, I mostly reside in Estonia, which is far, far away. So this is kind of great. And this session will be about Kubernetes. And I'll just explain a bit in a second, right? So I work at a company called Atomic Jar. We are maintainers of the test containers libraries. They are great for integration testing. And tomorrow there's another talk on specifically test containers. So that will concentrate more on the library usage and like what the normal use cases for that is. But it's just something I do. And this session, I came up with the idea, because my background, I work as a developer relations person, but my background is being a developer. I was a developer like in different Java organizations for something like 7, 8 years. And that was some time ago, before Kubernetes was everywhere. So, and then Kubernetes became everywhere, and I realized that I need maybe to learn what it is. And then somehow, like I never needed to learn what it is. Because very often, we can just go and do our job as developers and not touch certain technologies due to any sort of reasons. Because, there are different practices because you work on different types of projects. If you're doing libraries, for example, right? Like you never need Kubernetes. If your main work is doing, I don't know, some sort of like a collection of libraries or any legacy projects. So I didn't learn Kubernetes, and then somehow like I realized that everyone knows what Kubernetes is, everyone is very familiar with that, and I was like, I need to catch up, right? And then every tutorial and over every like explanation or how-to or all conference sessions, they were all kind of very complex. They started very easy, like, oh, Kubernetes is a platform that you can use for deploying your things, right? Running your workloads. And then on the second page, like it always goes into, let's create private networks and do the role-based authentication. And that's where like those tutorials lost me very often, right? Because, I didn't have like the urgent job-related need to figure out things. I didn't have to deploy anything in production. But I just wanted to learn, and it was hard. So then I realized that there is a very interesting way how I can explore Kubernetes and the concepts and what the components inside. And I figured out that I should do a session. And we're going to draw an owl, and it's not going to be the most realistic one, right? This session will not teach you everything you need to know. This session will, maybe it won't even teach you anything. In a sense, anything new. But I think I will try to provide a sort of a way into how you can explore technologies in a very sort of Java-centric way. So what we're going to do, we're going to use test containers. We're going to spin up Kubernetes clusters in the test containers managed by test containers. And we're going to sort of interact with them in different ways. And see what will come out of it. So we're going to sort of explore what Kubernetes is in a safe, repeatable, ephemeral environments provided by test containers. And if you know what Kubernetes is, and if you're like, we will not get to the point where we're going to deploy things and update things and then scale things and the intricacies of the configuration options and whatnot. We're going to touch on the basics. Right? So if you feel that you know quite a bit about Kubernetes, maybe a session by Alex in the parallel room is a better fit. So this is for people who didn't finish a tutorial on what is Kubernetes, and so this could be one. Right. So what is test containers? Those are the libraries, and they integrate with Docker. So we're gonna run everything in Docker containers, and we're gonna try to interact with those things from our Java applications. Normally, those would be like test containers are mostly focused on the, test, right? There is a hint in the name, but it doesn't have to be. The API is universal, and you can write any program and it's just the difference between a program and a test is that the test asserts something, right? And so if you don't assert anything, like you can use whatever, and we're going to use that. So we're going to use test containers for container lifecycle and the configuration of the services, and to have a convenient way to look at that from a Java application. So we're going to not see any YAML. I think there is no YAML in this presentation about Kubernetes, which is I consider as a personal little win. And yeah, so the whole integration will be provided by test containers. And it comes with a ton of modules, and one of them is there at the bottom right, is Kubernetes. So we won't even have to hand roll our Docker containers and say ooh, I want to create the Kubernetes, and I need to run those processes in my Docker container. But we're going to use the predefined library that somebody who knows what Kubernetes is has written for us as a test containers module. So our application code will be much, much simpler, and it will allow us to maybe concentrate on the components within the cluster. Right. So that's it. It's there is a very brief introduction, right? And then let's spin up clusters and let's try to see what we can get from them. Let's go to the IDE. Let me show you a little bit of the setup. So this will be our setup. View, enter presentation mode. This is our code. So if we look at the POM XML, okay, we have all our dependencies here. This is what we're going to work with. We're going to work with test containers, and we're going to use a module for K3S, which is an implementation of Kubernetes by Rancher Labs to spin up the Kubernetes clusters. We have other dependencies that are test container specific there as well. We have the integration with JUnit, so we can run tests easily. We have integration with Postgres, so we can spin up Postgres easily. We will use Fabric 8 Kubernetes client to interact with our Kubernetes cluster. So we don't have to write YAML files and use the command line kubectl commands to integrate with that. And that's mostly it. The rest is there's just the normal libraries that we have and just as a helper libraries. So let's see what we have. We have a normal class, and there is just one method that we have a test. I don't know why it's a test. It doesn't have to be a test actually, but since I had test containers, in my mind everything was a test. So this is what we'll do. We create a K3S container, and we're going to say that we're going to want to run this Docker image in that container. And this Docker image, this is of course the K3S Kubernetes implementation by Rancher Labs. What it does, it's an implementation of Kubernetes, right? So it does everything that Kubernetes needs to do, but it also can run in a single node environment very efficiently. There are some processes that in the normal Kubernetes cluster could be different separate processes. They are put in a single binary for simplicity. Data store that usually would be a distributed thing in a normal Kubernetes cluster. There is by default is SQLite because they are intended to be run in a single node environment to be lightweight and fast. So we're going to use that. It's very convenient for us now, and we're going to see what we can do. So we spin that up. We create that. We say that we want to start it, and it will start. The test containers will download the image. It will run it. We will get the Kubernetes cluster, and then we can get the config from the Kubernetes cluster. And behind, in that string, there will be YAML, right? But we will not see it because it's in the there is we do everything through programmatic API. So there will be YAML. We'll create the config, and then we're gonna just do some operations. The basic thing that you can do is you can create a namespace, which is just a sort of a namespace, right? We're gonna get a separate isolated environment in which we will mess things up. And then we're going to run the command, and then we'll do a sort of a break. Because then at this stage, I would like to explore my Kubernetes cluster. I would like to see what's running in my containers. And you could do that with a breakpoint. But I'm old school. I don't trust my debugger very often. Sometimes I trust it when I need to actually debug things. But when I just need to stop the process, we're going to use the scanner trick. Don't do that at home. That is not That is not recommended, but only for explorational reasons. So this is what is happening, right? I started this test, and this could, like any normal application, it will run, it will figure out that it needs to talk to test containers, through test containers to a Docker daemon. It will find the Docker daemon, and it will pull this image, and it will run that image in my Docker environment, right? And we're gonna see that in a second, that it will stop. It will do all that, and it will stop. And we'll go into the command line. So just why not, right? So we can look at what Docker containers we run. We are running the Rancher Docker image, and we're running Rook, which is a sort of a cleanup facility by test containers. So, and I think here we're all good. It will run. So now we can just go into that. So we go into this Rancher container, and we're going to see what's in there, right? The server is running. The container daemon is running, a couple of streams, and metric server, a bunch of processes. And we can do things with this. So it comes, Rancher image comes with kubectl. So for example, we can get namespace, right? And we see that our Kubernetes cluster is actually fully functioning, running, and it's a normal cluster, right? It has what does it have? It has the default things, and it also has a namespace called Oleg, which we created right here. So our application here works surprisingly well. So now we send the commands, right? Like we can create a new namespace. What's create namespace? Give me another name, Jconf, right? And then we can get the namespaces back, and we have another one. What does it tell us? It tells us that there is something in the Kubernetes cluster that can respond to our commands, and it preserves state between different commands. So there is this thing called API server, which will be responding to our commands, and it's a central piece of the Kubernetes infrastructure. It's a component that offers the end user the API to do things with Kubernetes cluster, and it offers the API for other components to do things with Kubernetes cluster. And there's the data store. Now, what sits in the data store? Like, now my next question is, can I take a peek? Because I know that like it's a complex system, right? And there are many things that are happening there. But I would like, as a developer, I would like to peek into the thing and see like what is actually the data this API server operates with. And what is that? So currently there is SQLite, right? And it's very inconvenient to look at that. And in normal Kubernetes cluster, this would be ATCD, right? Which is a distributed key value store, which could be, as it's distributed, not even in a single process or a single node, which is what's great. But it's hard to kind of peek into this. So we're going to do the following thing. We're going to just go and complicate our setup a little bit. So what am I going to do now? I'm going to run the Kubernetes, the Rancher, the K3s cluster, and I'm going to replace the built-in database with a Postgres instance. Because Postgres is something that I know how to manage as a developer, right? I'm going to spin up Postgres. I'm going to tell my cluster that this is your database. Use that as your data store, right? And then I'm going to connect that through my IDE. And I'm going to see how the data is, what data is there. Like, is it even possible? Who thinks it's possible? Who thinks it's impossible and it's going to fail for sure? It might fail, might fail, might fail. But I think it's possible. I think it's possible. We're going to try that. Who knows what's the data representation in the etcd? Like, what is it? Like, what will we see when we connect? No one? OK, very good. Then this is going to be interesting, right? This is going to be interesting. So let's stop this. And I have this setup more complicated. Let's look at the setup first. So this is what we're going to do. We're going to still have the Kubernetes K3s container that we're going to run the same way. But before, we're going to spin up the Postgres container. Because, well, I have test containers already here, right? So it makes sense to manage the database the same way. We're going to start the container, and we're going to create a URL that we're going to feed into the Kubernetes container, telling where my Postgres is. And then we're going to start, and we're going to do all the same things. And we don't even need these things, right? We just create the namespaces, and we run it. And we're going to see what's in there, right? So I think we can run this. Can we run this? Yes. Right. So it will take us a moment to run this test. It needs to download Postgres, I think. If the Postgres image is not available, it will pull it. If it's available, it will use the cached one. And now it's going to run this. And now we need to get and connect to this Postgres from my IDE. Wait, I need to exit my presentation mode because I don't know where it's in the presentation mode. So I would like to connect to my Postgres running locally here from my IDE. And I want it to be the Postgres that is in there. One thing that I can do is to do Docker PS and check what is my Postgres and which ports are, well, actually, I'm going to just do that. So I need to say that my Postgres here, properties, and please use this port for Postgres test connection. OK, succeeded. We are in. We are in. We connect to that. Now what we need to do, we can look at the tables, which is quite ridiculous there. Look. And if we, right. Right. This is all the data that Kubernetes stores in its data store. There are a bunch of things. What's interesting is it's a key value store. Like etcd is a key value store. So in our Postgres instance, and it is represented by a table called kind with the name and the value. Isn't it funny? I think it's pretty interesting, right? So I'm gonna now filter by Oleg because we created the namespace called Oleg. And here's the thing. So we have the namespace, and this is it. And it also created a bunch of additional things that are required for this. For example, a service account that comes with namespace. Now here's the question. Who created that? Do we think that our code created that? No, we just said create a namespace, and we ran it. Do we think that the API server created that? No, it would be a violation of the responsibility principles, right? There is a third component that is responsible for creating things, and it's called a controller manager. And there are a few processes that are in there that look at the state in the API server and subscribe to certain events that happen in the API server, and then they do something. For example, when we create a namespace, they created the service account for us, which is those things, right? And then there is also the node manager, and there is also some other responsibilities in the controller manager. But this is the third entity that looks at our API server data and does something. And this is how Kubernetes works in general, right? API server is the central piece of infrastructure that everything sort of connects to. And then you never say what you never command Kubernetes to do anything. You mostly say, I would like something to happen. And there are the responsible parties. The API server changes the state, the desired state, and the responsible parties kind of look at that state and they on the changes that they subscribe to, and they do whatever is necessary to get your cluster into the state that you wanted. So we created the namespace, and the controller manager looked at that and said, "Oh, we need to create a service account for that," and we didn't command that. So let's see if this actually works, right? So we created that through our code. So let's see. If we go into this another container, wait. Okay, this. right? And we do kubectl get namespace, right? We have Oleg there. Now, what I'm going to do, I'm going to delete this row. No, which one? The namespace. I'm going to delete it. Will it break my Kubernetes cluster? No. What if I commit the changes? It will not. It will not, because, well, the data is still there. We didn't, like, nothing even happens, right? Because the changes didn't go through the API server, right? Nothing, no callbacks into the other things happened. So the service accounts are still there. Everything is still there. But like, what's interesting, that the namespace is not there anymore, which is sort of funny. But the Kubernetes cluster obviously works. It just doesn't find the namespaces, so it doesn't find any associated things with those. I can recreate the namespace, and then everything will be as good as good as back. Wait, let me just create this again. Kubectl, create namespace. Oleg. Namespace is created. We can get it back. We see it here. All works as supported. Let's do a secret. Ooh, namespace is Oleg already exists. This is interesting. Oh, because I have two of them. Okay, right. Let's create a secret, which is the sort of additional object that represents encrypted data that you can use in your deployments. But it's just a convenient thing that we can create in the namespace. Create secret generic Jconf, right? Jconf. And then I think namespace. Oleg, right? OK, we created the secret. And we can see it here, right? Secrets. Jconf. We created the secret. It's an empty JSON that is sort of confirmed. And we can do that. We can operate that in the namespace, right? And now if we delete the namespace, I think everything should be deleted, right? kubectl delete. Right? Is everything gone? Everything is deleted, right? I clicked the wrong thing. OK. We're going to disregard that. I clicked Command R, and it rerun my tests. So I'm not sure what happened there. But we can interact. We can interact with the components. We can interact with the database. We know that there is the control manager that does part of the job for us. So now the next thing that we want to do, we want to look at how we can deploy things. What does it mean to deploy things in the Kubernetes? And most of the tutorials talk about pods, which is a low-level concept, which is the sort of a unit of deployment that will contain your application. And I think this is very confusing. At least it was very confusing for me. So what I want to talk to you about is a deployment. A deployment is the API object that is responsible for running your application on Kubernetes. You can create one. You can specify what application you want to run. It could be your application, or it could be any predefined other people's application. And you create and you say, I want to run a few instances of that. And then it runs. So here's another test that we're going to run. Let's look at the code there. Let's look at the code there. So we do the same thing. We create the Postgres. We create our Kubernetes cluster. We get the config. And then we create the namespace. And then we create a deployment. So, and this is what you would do in YAML. But it's so much better to do in using the Java API. Because here IDE supports me, right? I can do with name. And I know that this it will compile all the time, right? So what we do, we create a deployment. We specify the amount of replicas, how many times we want to run this application. We call it Oleg. We say that we want to run the container that is Nginx. And we run it, and we're going to run this Docker image, and we're going to expose the port 80. And this is also the whole deployment. There is a lot of boilerplate, but the important parts are that we want 2 engines running in our Kubernetes cluster, and then we create and then run it. That will create, the deployment is the object that is responsible, declares where and how we want to run our applications. Now, will our API server run our applications? No, it's not its responsibility. It's also not the controller manager. It's not also obviously not the database. So something will run our application, and that's where we discovered the next concept, which is a kubelet. So the cluster will sort of is divided into the worker nodes, where like a part of the cluster is responsible for running things, and a part of the cluster is responsible for configuring things and ensuring that all the parts run smoothly, right? So the worker part of the cluster that will run our applications will run processes called kubelets. They will connect to our API server, and then it will listen for the changes in the internal database, in the data structures. And then when we tell the API server that we want to create a deployment of 2 engines, it will send the signals, and it will schedule where those replicas need to run. And then kubelets will go and see, like, do I have something to run? And then they will get the response that you need to run engines, and then it will start running that container. This is all there is to deployment in the very hand-wavy terms. But it doesn't expose anything, right? It just creates the individual units of deployment, and they run somewhere, and we can sort of access that, but it's a little bit inconvenient. So wait, in this one, do we create a service as well? Yes, no? OK, we're going to create the deployment just right like that. We're going to create the deployment. Let's run it. What is very good here, and this is one of the benefits of the approach, is that I can never kind of mess up my configuration, my cluster, to the point of no return. It's very ephemeral. I can always restart it. It always restarts in the same way. So it's a great way to explore the technology. So what we do this, what is this test doing? It starts the cluster, it runs the cluster, it creates the pods, it creates the deployment. Sorry, clicked too much. It creates the deployment, and then it waits. It waits for us, right? I think it waits for us. Right, it waits for us. Let's see, can we do this? Can we connect to the database? Where's my database? I have a trick here where I create a local proxy, because my ports on which things are exposed are very dynamic. So I create a proxy on the particular port. So just my database is here always running on that port, because I proxy it in. So I think if I do this, it's still supposed to work. OK. Something didn't work. OK, this is just, ignore this. This is not important, right? So our database is there. Let's see, do we have deployments? Do we have pods? Look, there is a lot of things that are created in there. So we have a bunch of pods running, a bunch of information about the pods, and we can get them. Wait, pod. Right, even more here. So we created the pods, and we created them in a deployment. Docker PS. Let's go in. Let's see. Maybe we can kill one and see whether Kubernetes will restore itself. I think this is an interesting thing to try. Docker exec. Right. We go into our Kubernetes cluster. We're going to say kubectl get pods. Namespace. Oleg. Very good. We have 2 pods running. PS. So we have 2 nginx things. I think if we kill one of those, the pod kind of sort of dies, right? Let's try. Wait, namespace? No. Didn't it die? It didn't die. Right, wait. How do I kill it? Can't kill no such process. Why is no such process? Yeah, but why is the age the same? Well, it's supposed to restart itself, right? Because like it's supposed to restart itself because Kubernetes still wants 2 pods, 2 replicas of the deployment. It's supposed to have 2 replicas of the deployment. And then if one of them dies, it looks at that and says like, okay, well, something happened. I need to reschedule that replica of the deployment. And it schedules another pod to run. But I'm not sure why we're not seeing it here. Right. Yeah, but isn't that enough? It should be enough. Oh, yeah. Yeah. Oh my God. Yeah, so the pod restarts the process. Okay, very good point. Let's ignore that for a second. Right, so how do we access those deployments then? We know that there is a deployment object in the API, like in the model, right? And there is implementation of that deployment, which is the pod processes running in our kubelets, which is technically in the same node, because here is like all one container. But practically, it could be anywhere distributed throughout the things. So there is an implementation of that deployment process. How do we access our application? Do we go directly and do we ask Kubernetes, oh, I need a pod with my Nginx. Can you give me the IP of that? Of course not, right? That would be very inconvenient. So what we do, we create a service, which is an abstraction that will kind of wrap our deployment, and we create a service, and we say that this service provides the kind of sort of the pathway to those pods. So when we kill the pods, or the pods die, and they get rescheduled into different nodes, or nodes die altogether, and the pods get rescheduled everywhere. So the Kubernetes cluster still keeps the internal map of infrastructure. And whenever we go into the Kubernetes cluster, it routes us to an available alive pod. This is what we're going to do, right? It's going to be here, right? So this is the thing where we create this service. And then I think that it will come together, and we will be able to access our what? Our Nginx in our container from the outside. So let's look how we create this service. We create it approximately with the same way. We're going to say that we want a type of node port service, and we're going to with the same selectors that we used for our deployment, which create the app by a name. And we say that we're going to proxy the ports 80. So the target port is within the container, the port is outside of the container, and node port is the external port that we can access through Kubernetes to our we can access our service through that node port. So we're going to create the service. We're going to run this. We're going to run it in our thing. And then what we're going to do, we're going to get the URL from where our Nginx is running. And then we're going to access that. And I think it's supposed to work then. Let's run it. Right. This gets very, even now, for me, it gets a little bit more complex than I would like. I would like this to be much simpler. But this is really the very basic that you can do. But at least we are going through the components and the necessary data model that Kubernetes uses, so we can have the basics figured out. Right. It's all going to run. and then it's going to spit out the URL here. And we expose, when we created the Kubernetes, because we knew that we need the port 3001, which we declared here as a node port. We need our Docker container in which we run our Kubernetes to expose that port to the outside, so we can touch it from the outside. So here in the Kubernetes description here, we say that we want, in addition to everything that is being exposed, we want to expose port 3001, so we can access it from the outside. So now on my host machine, I can access whatever port was mapped to. It will go to the Docker container that runs our Kubernetes, access that port 3001 in there, and that will route it to whatever is described to the deployments of our application that is connected to that service. So if I go to this URL, I think we should see an Nginx starting page. Who believes in me that this would work? I don't. The previous demo didn't work. But we do see Nginx, right? So and this Nginx is running in my Kubernetes cluster. So there is a deployment. There is a service that proxies our request to that deployment, to that implementation of that deployment using pods. And we can access that from the outside. So this is one part. Now, technically, we know enough to take our application, say it's a Java application, wrap it into a container, and then deploy it in the Kubernetes cluster. Now, the opposite question is, so we can access our application. What if our application needs to access some resources? What if it needs to access a database, or Kafka, or whatever else, right? Locally, we can tell to our application, oh, here's Kafka, or here's something. How do we do that in Kubernetes? We need to provide configuration. And that configuration should be preferably separate from the actual deployment description, or even worse, the individual pod description, right? Because those will be managed automatically. So what we need in another like API object, another data model that will store our configuration for us and apply it to the necessary deployments and the implementation of the deployments, which is pods. And that object is, of course, a config map. And config maps they're a very flexible concept. You can create that from files. You can create that from values. You can create that from volumes, directories, and you can consume them on the pod side in all those ways as well. You can specify the configuration that, oh, please, my application, take the value of JDBC URL from the config map called Oleg that is provided to you by Kubernetes. Or you can say that, oh, when you create this pod, when you implement my deployment, create a replica for that, please map that config map as a volume into the file system so my application can read, I don't know, property files from the file system. So it's a very flexible concept. But in the nutshell, this is just the configuration that is managed by the cluster. And it sits where? It sits in our control plane. It's created there. And it just passed and worked with in the workers when we deploy things. So I think this is supposed to be the force test, right? The force test. So we do the same thing, and somewhere in the thing, and Nginx will not use our database. Nginx doesn't need my database. But what we can create, we can very easily create a config map. And all those configuration things, they're also, of course, available in the YAML form. You can create YAML files that describe the same objects and entities, and then say kubectl apply and give it like a piece of YAML, and it will apply and it will change the state in the database, in an internal database. So, but here we do this programmatically. We can create the config map, and we, for example, can say like, oh, my JDBC URL, and that would be whatever JDBC URL do you have. It can run in the Kubernetes cluster if you have a database running in the Kubernetes cluster, or it can run anywhere else. It can run like as an on-demand planet scale instance of MySQL. and then you just get the URL and you access that through the internet. Or it could be, I don't know, like a database in Oracle Cloud or whatever else other service that you need. It doesn't have to be within your Kubernetes cluster. It can be elsewhere. But it also can be within your Kubernetes cluster if you want. And then you can use it through the service discovery or through any services that encapsulate the deployments of your database, for example. So we can create that. We can create a map of that. We can run it. And then on the pod side, we can use that in whatever fashion that our application expects the configuration. There is also secrets, which are also sort of encrypted configuration. So don't put your allegedly. And I think it's maybe a minor point, but this is sort of security related, right? So like it's important to always think about that. Don't put your private things into config maps, right? Use secrets to use that. So maybe the password to your database would be a secret instead of being a config in the config map. Right. And then we can run that. And then we can create that, and our deployment will have access to those parameters, and it looks very much the same. So I don't think I even need to rerun that, right? Let's see our deployment, our service. Yeah. Do we have our database here? Let's see. I want to see my service. Yeah. So we have endpoints. For the Oleg, and we have, what else do we have? Yeah, service account. This is a bad query. Okay, so we have a lot of data. And if you can, I can give you the application there, and you can try it, and you can explore what you can do with a Kubernetes cluster this way, right? This sort of sums up the demos that I wanted to show. And let me just recap a few things. So what we did. We learned of a few basic components that now take part in our Kubernetes cluster. The API server, the etcd, which is the data store, which we replaced with Postgres, which I was very surprised that it works. But it works for K3s by Rancher because they created it this way as a Kubernetes implementation. So we learned that there is a controller manager, which is the entity that creates other additional data models in our API server. We learned that there are kubelets, which are actually running our deployments, our applications, and they form our data plane. And we learned of certain concepts, and the most important ones are probably for the very basic usage is the deployment, which tells us where we run and how much we run things, which is services, which expose the deployments to other things within and outside of the cluster, and the config maps to provide configuration so our deployments and our applications within deployments could access third-party resources. And it all runs in pods, which you almost never interact directly with. So it's very interesting that it's such a fundamental concept, but nothing actually interacts with it directly. Unless you get into more complex scenarios, service meshes, and then you would have sidecars within the same pods, and then sort of you need to understand what the pod is. And there is, of course, there are a ton of resources which you can look at. Probably the Kubernetes docs are very good. They're very extensive, so it's sort of hard to, from zero, it's maybe very hard to read them top to bottom. But if you have particular questions to the docs, they are very, very good. So finding answers to the questions are extremely easy, and just maybe I didn't find the story, or maybe I'm just a very Java-centric, with a Java-centric background and couldn't do that. For the experimentation, you probably don't need to roll out your own Kubernetes clusters. Very few people do. So it is probably better for you to go to any cloud provider and ask for a Kubernetes cluster. Or you can, for experimentation purposes locally, you can just try whatever the approach that I showed, or run it within Docker containers yourself, or run something like Minikube, that is the implementation of Kubernetes that is specifically designed for like individual developer workstations. And then you can interact with that, and then you forget the configuration that you did in the previous time, and then 2 weeks later you interact with it again, and then there are interesting things to debug. You are welcome to try to follow the Kubernetes the hard way by Kelsey. It's way over my head, so that was one of the parts, like one of the reasons I decided that this could be a good session. And if you want any information about test containers, you can check on it, or if you can come to another session by me tomorrow, where we talk about test containers. And there I actually know more things. So Kubernetes is very, very foreign for me. Test containers is very close to my heart. So that's it. Thank you very much. And I think we have a little bit of time for questions if we have questions. Very good.
So I am someone who doesn't know anything about Kubernetes. So even this was a lot of new concepts for me. So what would be a good resource for me if I don't know anything? Like you said, I can go to this Kubernetes basics, and it might be a lot of information.
Yes.
But to start from scratch,
So this is a very good question. How do you start from like very, very scratch? Yeah. If you feel that you're a type of person who learns best from books, the docs are a good place, right? There's a getting started tutorial, which is very basic. They're a little bit, most of them are a little bit operations specific, right? So how to look at that from the sort of the operations person. Okay. But there are definitely, yes, there are definitely very basic tutorials for beginners from the. I think even this Kubernetes basics, I think this one is not about creating clusters and everything, but this one is supposed to be very basic. So I think you can try from this one, right? So look, deploying an app, exploring your application, exposing your app publicly. I think this basics one will be good. If you feel like you're a person who you want to experiment with things more, right? Yes. Then you can follow the examples that I showed here. I will have a GitHub repository link soon, somewhere, right? And then you can experiment with it, at least with the very basic concepts, right? And I think so what helped me here very much is that I could look at the database and kind of think about oh, what happened? We do this one thing, we create a namespace. What happens inside? And that, I think this is a good approach for somebody who tinker with things more than try to read and yeah. So you can definitely, as a beginner, you can just tinker with some basics, and here everything is described as code, so it's a self-contained thing. Okay. So it might be an interesting approach.